In this example, we're going to be doing law of sines, ambiguous case, and we're going to start to go through different situations and see what we got going on. So again, just a quick refresher, the ambiguous case is potential for more than one triangle, and it only have to worry about it when you are given a side, and an angle. So you are given a side and an angle across from each other with an additional side. So if that's the case, very first thing you want to do is you want to compare and see if this side across from your angle that you know, if that side is bigger than this side, then it's going to be too big because this piece has this potential to swing and cause two triangles. So if this side is too big, it's going to swing and not cause a problem at all. And then it's kind of A is a Goldilocks thing. If A is somewhere between these two values, then it's going to create two triangles. If it's equal to that value, it's going to create one triangle, and if it's too short, you're going to create no triangles at all. So it's hard to tell what situation you have. Let's draw a picture and let's see what we got. First thing that I want to recognize is I do have a side, and an angle, but that doesn't guarantee that I have it exactly in this order. But the fact that I have the side and the angle across from each other, they're both C's, I definitely have a side angle situation. But I don't know what kind of Goldilocks. Do I have a Goldilocks or do I not have a Goldilocks thing? So just going to draw a picture, see where it starts, see where it goes. So I draw my picture purposely like this 100% of the time. I don't connect this side because this is my side that is going to potentially swing. I just don't know if I have that or not. So I force that to be, this ends up being my angle, and this ends up being my side across from it. So that's 38.4. That's 41 degrees, 20 minutes. And then my other side is 25.9, so I force that to be angle B because that's going to be side B. So if I don't do it this way, I personally get all kind of confused and turned around as to which side potentially swings and how does it swing. So if I draw this every single time, this look, I know that this is my piece that potentially swings. So scenario-wise, first thing I'm looking for is I'm going to compare this to this. And the fact that this side is bigger than this side means I'm going to have one triangle. Because this side's going to be so far out here, because it's going to need to be bigger, that when you swing it across, it's never going to create a second triangle. So this is totally fine. It's business as usual. And so we are going to start to solve it. So there's something in this that I want to make sure you're good with the calculator part of it. But we'll start to set it up that I have one full fraction, so it's definitely a law of sines problem. So sine of 41 degrees, 20 minutes over 38.4 is going to be sine of B over 25.9. Cross multiply, so we're going to have 38.4 sine of B equaling 25.9 sine of 41 degrees 20 minutes. We're going to divide by this. We're going to divide by the 38.4. And then eventually we're going to kind of skip a step here a little bit, but in order to get B by itself, we're going to have to do the inverse sine. So the inverse sine of whatever this turns out to be, 25.9 sine 41 degrees 20 minutes over 38.4. Okay, so I just want to make sure that we're able to plug that into the calculator appropriately. So let me do that. We're going to zoom in. Okay, so we're going to plug this into the calculator and make sure that everything is good. So we're going to be typing in, do this a little bit closer, just so you can really see what's going on with the calculator. So we're going to do the fraction feature on this. So fraction, no we're not, we're going to do the inverse sine first, and then our fraction, and we're going to do 25.9 sine of 41, and then degrees is right above app is angle, so degrees 20 minutes, and minutes is the second one down. I can close that, go into the denominator, divided by 38.4. Close that. Now the problem is It's going to give us 26, but since this thing started in degrees and minutes, we're going to need to convert that into degrees and minutes. All right, so to convert that into degrees and minutes, I go back into my angle, and there's number 4 down is going to be converting it into degrees, minutes, and seconds. So I just press enter, let the calculator do its thing. So that 0.45 is 27 minutes. And then what I want to do is look to see if I round it. Now remember, this is seconds, so if it's higher than 30 or higher than 30 seconds would bump this up to make it a 28 minutes, but 8 seconds is not enough. So we're looking at angle B being 26 degrees, 27 minutes. Okay, so that is how I can use the calculator to kind of do all my conversions for me as I just naturally go through the problem. All right, so now once you have angle B is 26 degrees, 27 minutes, and then that makes angle A 180 minus these two, which gets me 112 degrees, 13 minutes. So I'll label it 112 degrees, 13 minutes, and then we need to figure that out. So then we go back to our original, it's just law of sines. So sine of 41 degrees, 20 minutes over 38.4 is going to be sine equal to sine 112 degrees, 13 minutes over little a. We don't know. So you cross multiply. A is going to be times sine of 41 degrees, 20 minutes equals 38.4. Sine 112 degrees, 13 minutes. Divide by our sine of 41 degrees, 20 minutes. Sine 41 degrees, 20 minutes. And that puts little a at about 53.83 when you plug that into the calculator. All right, and then my last thing is I always like to just label everything to make sure all the pieces seem to make sense. Largest angle, largest side, smallest angle, smallest side. So everything seems to line up. I'm probably not going to get lucky with that. So if it lines up, everything's probably okay. So that was example 1 on ambiguous case, which was an ambiguous case, was not. It had potential, but the fact that that side was bigger than this side stopped it right away. Totally normal, business as usual. Do your law of sines. All right, example 1.